Hello, everyone. This is the Intech Center. We are a further education and training center providing functional skills, maths and English exams and courses as seen here. Today, we will be going over a sample paper from the City and Guilds awarding body. Please note that this video is to support the funded learners at our center and is for internal use only. Now, before seeing my solution, before seeing my solution to each question below, I strongly recommend pausing the video first and attempting it yourself in order to maximize your benefit and learning from this video. So let us begin now with the non-calculator paper. As you can see here, it's 25 minutes long, and there are 15 total marks available for this section. So please remember that you are not allowed to use a calculator in this section. And here we have question 1. Now we're multiplying 531 times 1.4. So when multiplying with decimals, the idea is to just multiply it as, two whole numbers and then add the decimal wherever you would need to accordingly. So here we have one whole number, which is already 531.14, and 531, and then we want to multiply by decimal 1.4. Now we have 531, and then the 1.4, we want to make it 14. So we just have to move the decimal place 1 over, right, to make it 14. So I'm just going to make a note of that, right? So then we need to add 1, the decimal, move it back 1 place because we've only moved it 1 overall in the whole number. So I'm going to multiply that. So here we have 1 times 4 is 4, 3 times 4 is 12, and we have to carry the 1. 5 times 4 is 20, and we add the 1, so that becomes 21. Then we want to add a 0, because now we're moving to the next digit. You're using the 1 now. So 1 times 1 is 1, 3 times 1 is 3, 5 times 1 is 5, and then we want to add those together. So we have 4 plus 0 is 4, 2 plus 1 is 3, 3 plus 1 is 4, and 5 plus 2 is 7. And then at the end now, we want to add the decimal back, right? And we want to move it, the decimal is normally here, right? Because it's a whole number now. Now we want to move it 1 over to here. So our answer will be 743.4. Now moving to the next question. We have 5 to the power of 4. So just as a general definition of exponents, right? So 5 to the power of 4 means that we're taking 5 and we're multiplying it by itself 4 times. So we have 5 times 5 times 5 times 5. Now, with BidMass, they're all multiplication, so it doesn't matter which order you do them in. So I'm going to just, take these two and do 5 times 5. That becomes 25. We have a multiplication in the middle, and I'm going to do these last two as well. 5 times 5 is 25. So we have 25 times 25. So we're just going to do that. So 5 times 5 is 25. Carry the 2. 2 times 5 is 10 plus 2, right? Remaining is 12. Then we add a 0. Now we're using this 2. 5 times 2 is 10. And then 2 times 2, sorry, 5 times 2 is 10. Carry the 1. 2 times 2 is 4. Plus 1 is 5. So now we add these numbers up. 5, 2, and 6. So our final answer should be 625. Now moving on to the next question. Here we have a parallelogram, and we have one angle given, and we're trying to figure out what is the size of angle A. Now, with a parallelogram, it should be noted that all the interior angles, so all of these as well, all of the 4 angles, add up to 360, right? And furthermore, we should know that, opposite angles are the same. So we should note that this angle here is also going to be 110 degrees. And this angle here, just draw it again, is also going to be A, right? So we know that if we add all 4 of these, it's going to be 360. So we have 110 plus 110 plus A is equal to 360. So this is 220 plus, and now A plus A will make it 2A equals 360. Now we want to subtract 360 by 220. So 360 minus 220. Now that will be 140. Okay, you can check that yourself. So 2a equals 140. And now, since this is 2a meaning 2 multiplied by a, we can, move that over by dividing. So we have a is equal to 140 divided by 2, which is 70. Okay? And this is all degrees, by the way, so 70 degrees. So that will be our final answer, 70 degrees. Moving on to the next question. Which one of the following works out to be the largest number? Now we have four options here, and we want to figure out how to do this, right? So we're taking a whole number and we're multiplying it by a fraction, right? So when doing that, you just need to multiply the number the numerator, right? The top number, and divide it by the denominator, which is the bottom number. So we have 8 times 3. So at A, we have 8 times 3, which is 24. And then we have 24 divided by 4, which is 6, right? Then the next one, we have 12 times 2, which is also 24. And we're dividing by 6 now. So that should be 4. Then we have 10 times 3, which is 30. And we're dividing that by 2, which is 15. And lastly, we have 36 times 3. So, I mean, we can just do it out as well like this. 6 times 3 is 18. Carry the 1. 3 times 3 is 9, plus 1 is 10. So we have 108. And we want to divide that by 12. Right? So now 108. I mean, this one will be a bit longer. Right? So, I mean, 12 times 12 times 8 will be 96, right? So that will be the closest. Because if you add 12 again, then you will get 108, actually. So 12 times 8 is 96, and if you add 12 again, you actually end up getting 108. So now that becomes 12 times 9 is 108. So 108 divided by 12 is actually equal to 9. Okay, I'm just going to remove this. So we have 6, 4, 15, and 9. So the obvious answer here is going to be C. Now we move on to the next question, where we have a percentage and it's asking us what is 52% in its lowest terms. So the key thing to note here, so it's a two-step process, right? We have to write it as a fraction and we need it in its lowest terms. So 52% as a fraction is just 52 divided by 100, right? That's relatively simple, but now we need to do it in its lowest terms. So we need to find the greatest common factor between 52 and 100. I mean, the first thing that jumps out to me is 2, right? Both can be divided by 2. I mean, there's probably an even bigger one, but I think for a starting point, you can just divide both the top and the bottom by 2, right? So divide by 2, divide by 2. So then 52 divided by 2 is 26. 100 divided by 2 is 50. Now, you can actually divide both the numerator and the denominator again by 2. So I'm actually going to do the same thing again. Divide by 2, divide by 2. 26 divided by 2 is 13, and 50 divided by 2 is 25. Now, can we simplify this any further? Well, 13 actually has no factor. Technically, it's also called a prime number. And 25 only has, well, 5. And, well, then you have 25 and 1 itself as divisors, but 5 is the main thing, and so there's nothing common between them. So that is the lowest terms, and that will be our final answer here. Okay. Next question. If the wheel is spun again, what is the chance of diamond being the winner? Give your answer as a fraction, right? So how many diamonds? So the idea of this question is to first see how many diamonds do we have, right? And from here, we can see that there's only one diamond right here, okay? And so our numerator is going to be 1, right? And then our denominator is basically how many options are there, right, overall. So counting here, we can see that we have 12. Okay, so 1 over 12. And there's no simplification. You can't make this any lower, so that's just going to be our answer. 1 over 12. Moving to question 7 now. Which calculation gives an approximation of the area of the circle in square centimeters? So what is the area of a circle, right? That's a formula that you should know. So the area of a circle is pi, oops, r squared, right? So we should know that. So pi is approximately, we can say 3.141, so on and so forth. But for this case, we're just going to use 3, right? As we can see, all the questions here have 3 in the beginning. Okay. Now, the main thing is to figure out the r squared, right? So they give us the radius r, which is 3.92. Now, 3.92, again, is we're trying to approximate, so that's close to 4, right? So we have 3, right? 3 multiplied by 4 squared, right? And so, again, BIDMAS, you do exponents first. So 3 multiplied by 16. And so the only answer here, obviously, is going to be C. Moving on to the next question. Now here is a proper BIDMAS question, in the sense that here we have, fraction, we have subtraction, we have, an exponent as well. So what I would personally suggest doing in the beginning is to just separate it out, right? Because you're doing a subtraction in the numeration, and then you're dividing as well. So what I'm actually going to do is split this divide and then put the subtract in the middle. By that, I mean I'm going to make it 8 divided by 8 minus 4 squared divided by 8, right? So I'm just sort of splitting it like this. It just makes it more clear and obvious what we're going to do. So I'm going to first deal with the left side. 8 divided by 8, that's going to be 1, right? And then I'm going to deal with the right side now. So we have 4 squared first, right? Exponents first, then we do division. So 4 squared is 16, and we're dividing that by 8, which is equal to 2, right? So the left side is 1 and the right side is 2, and we're subtracting. So in the end, we have 1 minus 2, which is equal to minus 1, right? So that's going to be our answer. Moving on to the next question. What are the coordinates of the line at the point star? So essentially, we're just looking here and we're trying to figure out what the coordinate is of this star. So coordinates, the way they work, we first want the x and then we want the y, right? So now the x, if we count first, we can see that we're here. So this is actually 5, right? So we automatically know from, 1 second, we automatically know from the options given that it cannot be A, it cannot be C, and it cannot be D. So B is the only option. But just to, complete the question, we have -3 here, right? So it's going to be 5, comma, -3. Okay, great. So now moving on to question number 10. So I'm going to zoom out a little. Which one of the following is the front elevation of the house from the view shown? So you essentially have this 3D model and you're looking at it from the front, and we want to see what is, I guess the diagram, the front elevation, right? So from the perspective of looking at it from the front, if you were standing, let's say as a person, right? And you're looking in this direction, what kind of shape would you see? So you can see that there's a little, we have a house with a little chimney on top, and we have a little square here on the left side, right? So from the following options, C is the only correct answer. Because if you look at B is actually from the left side, because you see there's a line here dividing. So you can see this line here, right? So that would be from the left. D would be from the right, since we don't see any kind of extension over here. And A would then be from the back, because then this would be on the right side versus on the left when we're looking at it from the front. Okay, so C is the answer to this specific question. Moving on. Now, here we have a commuter that uses both two, forms of public transport to get to work. The train is more than 5 minutes late 1 out of the 6 times they use it, and the bus is late more than five out of the, sorry, more than 5 minutes late 3 out of the 5 times that they use it. What is the probability that both the bus and train will be more than 5 minutes late? So this question should automatically, sort of scream to you that it's a tree diagram question, right? You're dealing with probabilities and you're trying to, see probabilities of two events happening at the same time. So one event is either the bus is, sorry, let's say bus or train respectively, since it's the same sort of situation with both. Now, either the bus or train is late, like either one of them is late, or either one of them is not late, right? So, and here they don't specify what the order is, whether they take the bus or the train first. And with respect to answering the question, it doesn't matter. So let's say you're at this point here, and let's say you take the bus first, right, for simplicity. So we take the bus, right? So now the bus is either, I'm going to say late, or I'm going to say not late. I'll put NL. Okay. So now it's going to, if the bus is late, more than 5 minutes late, it says 3 out of the 5 times that they use it. So this will be 3 out of 5. And then this will be the remaining. So 2 out of 5 times it's not late. So it's actually late more than it's not late, like more than it's on time, right? And then let's say you take the bus first, right? And then you have to take the train. So um, once you take the bus, right, then you need to see, okay, whether it's late or not, then the train is also late or not. It's the buses and the trains are not directly linked. They're independent of each other, right? So you still have two options now. The train can also be either late or not late, right? So I'm gonna actually maybe make this a little bit better. So this now we'll say this is train. This is also train. So now train can either be late or not late as well. So I'm gonna say here is late, here is not late, here is late, and here is not late. Okay, and the probabilities now for the train is 1/6 being late. So it's not late as often. So 1/6, it's late, and 5/6, it's not late. And I'll just write it here, 1/6, and then 5/6 is the same. Okay. Now we want the probability that both the bus and the train will be late. So we're following this first path where the probability is 3/5. That's for the bus being late. And then independently, the train is also going to be late, right? I mean, again, they're not linked to each other. The bus and the train being are separate. The fact that they're late are separate events. So we have then 3/5 and we have 1/6. And essentially the idea with tree diagrams is to multiply those numbers. So we're trying to figure out the probability of these two events happening together, right? That's why it says both. So here we have 3/5, and we want to multiply it by 1/6, right? So this is just going to be 3/30. Now, again, we always want to simplify, right? So when simplifying here, we can divide both the top and the bottom by 3. So I'm going to do that. That's the common factor. So then we get 1/10, right? Which also you can say 10% or 0.1. All of those are, forms of probability. So this would be your final answer. Either of the three are acceptable. Great. So now moving on to the last question. A model maker wants to make a model of a ship. He will use a scale of 1 to 50, okay? The ship was 100 feet long, and they give the conversion from feet into meters. And now they say, how long will the model ship be in centimeters? Okay, so now 2 points to note in this question is it's asking how, like it's giving you the actual, length of the ship, and he wants to make a model. And it's asking it in centimeters, and we're given the conversion to meters. So you should already know how to convert from meters to centimeters. That's an assumption, that's part of being able to pass this exam and in order to do this question as well. So first thing I'm going to do is take 100 feet and I'm going to convert it into meters. Okay. So now you're essentially taking like 0.3, or you could say 30%, right? So 0.3 is also the same as 3 out of 10 if you want. And we're trying to get 3 out of 10 of 100 feet, right? So here I'm going to multiply by 3. So similar to the earlier question that we did, I'm just going to follow a similar format. So we take 100 multiplied by 3, which is 300, and we divide it by 10, which is 30. So 100 feet, we've now converted to meters, is 30 meters. Now here I'm going to use the scale, okay? So in the scale, we're trying to say that 1 centimeter, or let's say one, well, in this case, we're using the meters right now. 1 meter represents, no, actually, so now we have 30 meters. What I'm going to do next is, because our final answer has to be in centimeters, I'm going to convert 30 meters to centimeters, okay? So 30 meters to centimeters, we know 1 meter. 1 meter is 100 centimeters, right? And now we have 30 of them. So we have 3,000 centimeters here. Okay. So that's actually, so 3,000 centimeters is the actual length of the ship. And he wants to make a model where 1 centimeter of the model is equivalent to 50 centimeters of the real ship, right? That's how models work. It's a small scale down version, right? So essentially what that means is we want to take the 3,000 and we want to divide it up into 50, like divided by 50, right? To see how big the model has to be, right? And that answers the question directly. So I'm going to take, so I'll just put this in the square, but all of this work should also be done in the square, and you'll be typing this exam up as the exams are computer based. So you'll be automatically typing in the square. So 3,000 divided by 50 is equal to 60 centimeters. So 60 centimeters is going to be the length of the model ship. So just to sort of recap what we did in this question to make it more clear. First thing I did was I took the 100 feet long and I converted it into meters. Okay, with the conversion given here. So that was 30 meters, right? And here I, take 0.3 and I show how to, do the conversion. So we have 30 meters and our answer is supposed to be in centimeters. So you should know that with 1 meter is equal to 100 centimeters. So I'm converting that and I'm multiplying 30 by 100, which gives us 3,000, right? 3,000 centimeters. And then, so the 3,000 centimeters is the length of the actual ship, and we want to use it of a scale from 1 to 50. So for each 1 centimeter on the model means 50 centimeters on the real ship. So we want to take the real ship, divide it into 50. And so that means that our model will be 60 centimeters, where 1 from the 60 will be equal to, from our conversion, 50 on the from the 3,000, right? So that's how much detail has to be into the model ship essentially as well. So hopefully that makes sense. And I'm just going to write down our final answer here is 60, and centimeters is already there. So this is it for the non-calculator paper, and we will move to the calculator paper now. Great, so now we're on the calculator paper. Um, the duration of this paper is 1 hour, 20 minutes. And so you have a total of 45 marks on this section of the paper. So noting that the total marks for this entire exam is 60 marks, so 45 plus 15. And the total amount of time will be 1 hour and 20 minutes. And the previous paper was 25 minutes duration, so it will be 1 hour and 45 minutes. So let's move forward now to the first question. And please note that you can use a calculator on this. So you can just bring out your calculators now. Great. So now we're moving on to question 1, where we are asked 12% of 5,300. Now, the easiest way, especially while using a calculator, is to do, we know that 12% as a decimal is 0.12. And if we want 12% of something, or like, any percentage of a number, we want to multiply the decimal by the amount. So I'm just going to take now 5,300 multiplied by 0.12, and that will give us 636. And so that's going to be our final answer for this question. Moving on to the next question. Here it's just asking us to do a multiplication and correct to 3 decimal places. So that's the key component. So 23.3 multiplied by 0.463. So we will get 10.7879. Now we want it to 3 decimal places, right? So we only want these 3 numbers. So what we want to do is we want to check for the next decimal place to see if we need to take the third, the 7, should it be an 8 or should it still be a 7, right? That's what we're trying to check. So because this number here, the 9, is greater than a 5, it's, sorry, greater than or equal to a 5, we want to round this number up. Okay, so then our answer to 3 decimal places will be 0.788. Okay, that's going to be our final answer. Moving on to the next question. Which one of the following lists is in decreasing order? Okay, so decreasing order means that the first number has to be the largest, and the last number has to be the smallest, with each next number being smaller than the previous one. So the second number here has, for example, has to be smaller than the first one, and the third one has to be smaller than the second one, and so on and so forth. Okay. So the easiest way, since again you have a calculator with this, is to just, make the numbers decimals and figure it out. So I think it'll be easier to do this by process of elimination in the sense that, okay, the first number here should be the largest. So I'm just going to compare these 3 numbers first, right? So that will reduce the number of options that we have. So right now I'm going to do 315 divided by 100, which gives us 3.15. Then 200 divided by 57, which gives us 3.508, which I'll just make it so 3.508, which is close to, I'll say 3.51, right? Again, rounding, because the first one is also 2 decimal places. And then we have 3 and 2 over 7. So with this one, actually, when you have a mixed number, it's 3 plus 2 over 7, essentially. So I'm just going to do 2 divided by 7. 0.2857 is what I get. So 3 plus 0.2857, which is, add that to 3.2857, which I'm just going to round since the 5 here is bigger. So this is basically 3.29. Okay. So we know the largest now, the first number, which is the largest, is 3.51. So we know A is not true and D is not true. Okay. So I'm actually just going to move this 3.51 over here. Now the next number is the 3 and 2 over 7, which we know is 3.29, right? So 3.29. Now we need to look at this number, okay? 1,500 divided by 924. Figuring this number out will tell us our answer. So 1500 divided by 924. That gives us 1.62, 1.6233, so on and so forth. I'm just going to say 1.62. And so actually our answer is going to be B. Now the reason why it's going to be B is because the next number, if you see here in this part, is going to be, the 3 and 2 over 7, which we figured out is 3.29. So C can't be the answer because we're going from 3.51 to 1.62, and then we're going back up, right? So that doesn't follow, it's not decreasing order, right? So that eliminates C as well from being from being the correct answer. So our final answer in this question is B. And if we want, we can sort of just verify. So we have 1.62 here, right? Because it's all using the same 4 numbers, and 3.15. And then we have 3.29, and as we figured out, 3.51. So as you can see, this number, this number, this number, this number, it's decreasing order. So B is the correct answer in this case. So now moving on to the next question. What is the price of the phone before VAT of 20% is added? So we have 240 as the cost of the phone, and it mentions that includes 20%, like that is on top of a 20% already. And we want to know the price of the phone before the 20% is added, right? So when adding, the percent of a number, so we know that we have, so let's say the answer we're looking for is Z, okay? And when we, let's say, want to add 20% to Z, right? Because that's how we get the final price when you add tax. We want to multiply it by 1 plus, and what's 20% as a decimal? 0.2, right? 1. So essentially, this is adding 20%, and that we know is equal to 240, right? So 1 plus zero point 0.2 is 1.2. So we have Z multiplied by 1.2, I'll put it as 1.20, is equal to 240. Okay? So now to figure out what Z is, which is the original amount, we want to take 240 and we want to divide it by 1.20. So now doing that on our calculator gives us 200. So our final answer here will be 200 pounds. So always note to add units. Here they didn't add the units. So I'm going to put it here. I'm not that great at drawing it, but yep, the final answer is 200. Because if you add 20% to 200, you can reverse the operation, right, to just double check that we're correct. Will give us 240. Now we have this question here. We have three candidates, and we want to figure out what fraction of the votes did the winner get. So essentially, we want it in a fraction, and we want the answer in its simplest form. Now, the fraction that we have is going to be, so we want the denominator, right, which is the total number of votes, right? So we want to take 602, add it to 553, and add it to 350 is 1505. So there were a total of 1,505 votes. And the winner obviously is the one with the most votes. So that's going to be candidate one. So that has 602 votes. So 602 out of 505. That's the fraction of the votes the winner got. And now we want this answer in the simplest form. Now, looking at it from here, it does seem quite tricky as to like, what the factors are in dividing because it's not very clear, right? 1505, 602, pretty big numbers. And given that it's a 1 mark question, what I will say is just do 602 divide by 1505, you get 0.4. Okay, so if you do that on your calculator, now you have a calculator for this exam, so that's why I'm just taking advantage of it, is 0.4. Now, 0.4 is also the same as 4 over 10, right? Or you can say 40 over 100, right, as a percentage, or however you want to say it, right? So I'm just going to say 4 over 10. And now we can simplify that 4 over 10. We can divide by 2 on both sides. So I'll make it clear. We get 2 over 5. And that is the simplest fraction. Now, instead of taking 602, 1505 and, spending a lot of time, this is the quickest, the quickest way of answering this question. And again, it's only 1 mark. So if you might not have known this, then you can just skip this question and hopefully you'll still be able to, you'll do well. But we do this question here, 2 over 5, and that's going to be our final answer. So now we have this question here, and a parent fills out this form about her 2-year-old child, medical form, and they measure it with a tape measure and write that the child is 3 meters tall. Okay, and the receptionist at the surgery thinks that the parent has made a mistake. Is the receptionist correct? Now, 3 meters is also 300 centimeters, and I mean that's very tall for a 2-year-old child, especially. So the parent definitely did make a mistake. So the answer to take here is yes. And it's asking for an explanation. Now, since this is a 1 mark question, both the answer, like the box that you tick, and the explanation have to be correct and enough. Because let's say your explanation isn't enough, but you tick yes, you'll still lose the mark to the question. So you both have to be correct. So let's say like if you tick no and then you put, let's say, a correct explanation, or maybe you misunderstood the question, then you will lose the mark for this question. So the answer is yes, and an explanation you can give is like a child, 3 meters is there'd be a giant that reached to the ceiling, or maybe they misread, the number. So that's, the reason why. So I can just say 3 meters is too tall for a 2-year-old child. And that would be a perfectly reasonable explanation. The idea is to explain why 3 meters is not reasonable, and it's too tall, right? So that would be our answer for this question. So question 7 now. We need to change the width of a photo to fit into a magazine. So they're just showing a diagram. You want to take this photo here, which is originally 8.9 centimeters. Now note the units here, again, very important. And we want to shrink it so that it fits in this tiny thing, this tiny slot headshot over here. And the photo, it says that it needs to be 3.2 millimeters wide. So now the question is asking what percentage of the original width, okay, will the changed photo be? So the original width, right? Now I'm just going to convert the centimeters into meters so that we have the same units, okay? So 8.9 centimeters. So there's 10 millimeters in a centimeter. So you want to multiply centimeters by 10 to get millimeters. So then that's the same as 89 millimeters, right? So that's the original. And the photo needs to, so we're taking the photo from 89 and we're making it into 32. And now the question's asking us, what percentage of the original width will the changed photo be? So the original width is 89, and we want to figure out what is essentially the percentage change, right? So we want 32 divided by 89, right? And we want that as a percentage. We want to know how much of a percentage, like, is the 32 from the total 89, right? Is it 50% smaller? Is it 60% smaller? Or like of the original photo, right? It's not even asking smaller. It's not saying how much smaller will it be because that's just the difference, right? But we want how much of the original is it? So if I just do 32 divided by 89 and get that as a percentage, we get 35.955, so on and so forth. So I'm just going to say, so this is actually equal to 0.35955, which is the same as 35.9, I'll say 96, right? Just rounding, making it simpler, percent. So that is the original, the 32 millimeters is 35.96% of 89 millimeters. That's what the question's essentially asking, and hopefully that sort of makes sense. So 35.96 will be our final answer. If it was asking for the difference, then you would take, 100%, right? Because 89 millimeters, the original is 100%, and you're taking that shrinked version. So if it's asking for the difference, then you would take 100% minus 35.96, and that would be the how much you're shrinking it by. But it's just asking what the percentage of the original width it is, right? What is the actual photo? Sorry, this new photo compared to the original. So that will be our final answer for this question. So now we're on question 8. We've given, let's say this plan shows the building land and they want to know the area of this building land. And we have a map, like a scale over here, and what is its actual area, right? So we have a scale of 1. So for every one, let's say now we have millimeters here. For every 1 millimeter, we have 1,250 millimeters in real life, right? In the actual building site. And note our final answer has to be in square meters, okay? Because it's an area, and in this case, we want the answer in meters, like square meters. So the first thing I would do is actually scale the numbers, okay? So I want to take 16 and multiply it by 1250, which gives us 20,000 millimeters. And then I'm going to take 66 and multiply it as well. And that will give us 82,500 millimeters, right, in real life. And now we just want to figure out, so we've done the scaling. Now we just need to figure out the area, right? And we want the area in square meters. So the first thing we want to do is change the millimeters into meters. Okay, so now that's quite a big conversion. So we know from millimeters to centimeters, right? And then we know from centimeters to meters, right? So 1 meter has 100 centimeters, right? And 1 centimeter has 10 millimeters. So to go from millimeters to centimeters the other way, we want to first divide by 10, right? So I'm going to take this, I'm just going to divide, let's say 20,000 by 10. So that's going to give us 2,000 centimeters. And this will be 8,250, oops, centimeters. And then now to change that into meters, we want to divide by 100, right? So 2,000 divided by 100 gives us 20. So we have 20 meters, and this will be 82.5 meters. So we have 20 meters, 82.5 meters, right? And we want the area, so we want to multiply them. So doing that on our calculator, that will give us 1,650. And remember, it's square meters, right? Because we're multiplying meters here, multiplying meters here. So we want to make sure we have the correct units. Again, it's already written down, but again, it's very important to note this. So our final answer will be 1,650 square meters. Great. So now moving on to question 9. So an architect designs a shop refit. They need to work out the weight of an oak panel, and we have the dimensions and we have its density, right? And it's asking us for the weight in kilograms. And if you note the density, it uses kilograms as well. So it's actually a relatively simple um, calculation, right? So, sorry. So with 700, we have density 700. And I'm going to rewrite this as kg to cubic meters, right? As cubic meters. Now, you might, even if you don't remember, the density, weight formula and all of that, then I think the easiest way to sort of look at it would be that you see here that we have kilograms per cubic meters, right? And we have what we need is we need the volume, right, of the object. We have the dimensions here, m, m, and m. Okay. So the first step would be to multiply these three dimensions, okay, so that we can get the units in cubic meters, right? So I'm looking at this more logically. So doing 0.06 multiplied by 0.9, oops, multiplied by 1.5. That gives us 0.081 cubic meters. So that's going to be our volume, right? So volume, density, the formula, right? And weight formula. So you see that here is essentially like a numerator. So I'm going to look at the units now, okay, to help sort of figure out, to help figure out what we need to do here, right? So we have kilograms by cubic meters and we have cubic meters, right? Now, if let's say we multiply them together, right? Think of them as numbers or think of them as sort of placeholders, right? If we multiply them together, right? Let's say you have 2 divided by 5 times 5, right? Then the 5s will cancel out and our answer is 2, right? So similarly, if we multiply these together, the cubic meters, the units, right? Because again, we're dealing with units here as well. Units are very important. The cubic meters will cancel out and we will just get our final answer in kilograms, right? So just logically, it makes sense that we want to multiply these two numbers now to get our final answer, which is in kilograms, right? Which is going to be the weight, right? So I'm just going to remove this and I'm going to say 700 multiplied by 0.081. That's going to equal to, just put it on our calculator, 56.7. And again, we note that the unit is in kilograms. It's written down, but that will be our final answer. Now, hopefully that makes sense. Again, I'm just using the units here to explain how, like, why this formula logically makes sense, right? Again, this is something you should know, but if you don't, hopefully you understood this and you'd be able to figure it out during the exam as well, as a little tip. Great. So now we move on to question 10. where a cook needs to be ready. A cook needs to cook a turkey to be ready by 6 p.m. Okay. They will start at 1:30 p.m. So they have 4.5 hours for this turkey to be ready. It needs to be cooked for 45 minutes per kilogram of the total weight. Okay, so 45 minutes. So we need to know the weight as well. Plus 20 minutes and then left to rest for 45 minutes. So it's not 45 plus 20, 65 per total weight. Like that's why they've distinctly separated it. Um, so it's 45 per kilogram of weight and then 20 and then 45 on top of that as well. The cook has a 4.4 kilogram turkey, so we have the weight. Has the cook allowed enough time? Explain your answer using figures. Okay, so I'm just going to put some work here. So normally, again, when you're typing this, there'll be a lot more space, but we have 4.4 kilo. First, let's figure out how much time will it take to cook, and then we'll see if they have enough time, right? So 4.4 kilograms. So we have 45 minutes per kilogram of total weight. So I'm going to do 45 multiplied by 4.4, right? And that's going to give us 198, right? And this is 198 minutes, right? Plus 20 minutes, and then left to rest for 45 minutes, right? So when we add all of these minutes together, that gives us 263 minutes. So we need 263 minutes total to cook this turkey. Now we want to figure out, the next part is to see if that is enough time, right? So we want to figure out firstly how many hours and minutes this is, right? So we know 60 minutes is 1 hour, right? So then 2 hours will be 120 minutes, so on and so forth. So 260, I'm going to just take 263 divide by 60. And that gives us like 4.38 on the calculator. So we know it's 4 hours and some other minutes. So now 4 hours is 240 minutes, right? So, and it's, so we have a leftover of 23. So we have, so the total cooking time in hours and minutes is 4 hours and 23 minutes. Now, if you start at 1:30 and if you add 4 hours and 23 minutes, that will become, so we can just do that calculation here. They will finish. So 4 plus 1 is 5. And then we want to take 30 minutes, like, because you're 30 minutes past 1. And we want to add 23 minutes. So that will actually be 5:53, right? So that's when they will actually finish their cooking. And it's ready by 6 p.m. So I'll just make it more clear. So they will have enough time, right? So the answer is yes. Okay, so all this working that I've done above, you will fill into this box as you're typing it in your exam. Okay. And so the explanation is that it takes, what, 4 hours total cooking time is 4 hours and 23 minutes, right? Um, so, so if they start at 1:30 p.m., they will finish by 5:53 p.m., which is before 6 p.m., right? That's the whole idea, is we want to see if we can cook this by like before 6 p.m. And that's what we were able to do. Okay. So that's how you sort of want to provide your explanation as well. You want to make it very clear so that, they will give you the marks for the question, because the way that the exams go is that they give you, they try to do positive marking. So whatever explanations you can give, if you can make it as clear as possible, that, okay, because it has to be in context of the question, right? It's not just about doing the math correctly. especially given that this question is 4 marks, you also want to give a suitable explanation. If you don't give an explanation, you'll most likely lose 1 mark. So total cooking time is 4 hours and 23 minutes. If they start at 1:30, they will finish by 5:53 p.m. And again, you make that very clear that it's before 6 p.m. as well, so they have enough time. So I'll just say they, oops. So I'll just say no. Say it like this, they, or I'll say the cook will have enough time. Therefore, there we go. Therefore, the cook will have enough time. So this will be our answer for this question. And here we've used figures, like if we show our, put everything, show our working, we've used the numbers, we've shown 4 hours, 23 minutes, so on and so forth. So it's very clear. Great. So now we move on to question 11. So Cafe wants to make its own coffee blend, mixing different coffee beans together, uses Brazilian beans and Kenyan beans in a ratio of 4:1. So for every four, let's say 4 beans of 4 Brazilian beans, you put 1 Kenyan bean in it. Manager needs to make enough beans to make 120 cups of coffee. Okay. And each cup of coffee needs 180, sorry, needs 85 grams of beans. He needs to know what weights of beans to use, what are the weights of beans he needs, and it's asking us specifically in kilograms as well. And we have here noted in grams. Okay. So now you can kind of do this 2 ways in the sense that you can figure out the total number of grams needed for 120 cups of coffee and then figure out how many grams you need in, what do you say, in of the Brazilian beans and then figure out how much you need of Kenyan beans. Or you can figure it out from the cup of coffee and then multiply the 80, multiply each of those by 120. So I'll do it the first way so that we have 85 beans for each cup and the total number of cups that we need is 120. So the total number of grams that we need for 120 cups, so I'm going to do 85 multiplied by 120. That gives us 10200 grams for 120 cups of coffee. Right. So now let's say you have, right, so let's say you have 5 grams, right? Because you have 4:1, right? So what that means is, let's say you have 5 grams. 4 of those grams are going to be Brazilian. I'm just going to put Brazil. And then 1 gram, the remaining 1 gram will be Kenya. Okay. So we want a ratio of 4:5 for this, and then 1/5 for the Kenya. So in that sense, we want to say that from this, 4/5, or let's say we can say it is an 80% of the grams, right, is going to be for Brazil. And then 1/5 or 20% is going to be Kenyan beans. So now I'm going to take 80% of 10,200. So I'm going to take 10,200 multiplied by 0.8. That's going to be 8,160 grams for Brazil. Okay, I'm just going to put equals here. Equals, so 10,200 multiplied by 0.2, which is essentially the remaining. It's going to be 2,040 grams of Kenya beans. Now, again, we noted in the beginning that our units are in kilograms, so they want the final answer in kilograms. So kilograms meaning there's 1,000 grams in a kilogram, right? That's what kilo means. So I'm going to take 8,160 and divide it by 1,000. That gives us 8.16 kilograms of Brazilian beans. And lastly, we have 2,040 divide by 1,000, which is 2.04 kilograms of Kenyan beans. Just gonna write it here. There we go. So hopefully that makes sense. So now you could have, again, as I said, so I took the total 10,200 and then figured out the 4 out of 5 and the 1 out of 5. But you could have also taken from 85, you could have figured out, okay, 80% of this for the Brazilian, 20% of this, and then just multiplied those numbers, those respective percentages and numbers, those grams by 120, right? Because that's for 1 cup and you need 120 of those. So you could have done it that way as well, and you would end up at the same answer. Great. So we are now on question 12. We have a man who wants to essentially, he has a certain height and weight, and he wants to reach a healthy weight. A doctor says he can lose 0.75 kilograms per week. Okay, if he follows a diet and exercises to burn 600 calories a week. So he plans his diet and decides to use yoga exercises to burn 600 calories a week. Okay, so 600 calories essentially is going to make him lose 0.75 a week. So he's already, and it assumes that he plans his diet and uses his diet. He will use 1 hour yoga classes that will burn 200 calories. Okay, and each class costs £6. He has 360 pounds that he can spend on yoga classes. They give a chart saying what's healthy, unhealthy. And it asks, does he have enough money to pay for the yoga classes? So the maximum he can spend is 360, and we need to see how many classes he needs and how much that will cost in total and see if that's less or more than 360 to answer this question. Okay. So first thing to note is he's 185 centimeters tall and weighs 98 kilograms. So 185 is from here is on this line here. I'm just going to put 185. Okay. And what does it say? He weighs 98. So that will be here. So he weighs this much right here, this dot. Okay. So that is, in the unhealthy territory, and he wants to become healthy. So how much weight does he need to lose, right? It doesn't tell us that, and we need to know. We know that, okay, he can lose 0.75 in 1 week, and we need to know for how long he needs to do that so he becomes healthy, right? So essentially, to be healthy, he needs to reach this weight over here. His height's not going to change, but his weight, he needs to go now to 86, right? So he needs to essentially be 86 kilograms, and this is what, 98, right? So I'm actually gonna this here. This is 86 kilograms. So he needs to lose 98 minus. I'll make it clear. So 2, 1, he needs to lose 12 kilograms in order to become healthy. And he loses 0.75 kilograms in 1 week. Um, so he needs to do that. So we need to figure out essentially how many weeks he needs to, do these yoga classes, and then we'll figure out how many yoga classes he needs and whatnot. So if he loses 0.75 kilograms a week and he needs to lose 12 kilograms, so we do 12 divided by 0.75, right? So that means that he will need 16 weeks. So 16 weeks of losing 0.75, 0.75, 0.75 to lose the total 12, right? So he needs to do 16 weeks of these yoga classes and exercises, right, in order to become healthy. So now we know that he needs 16 weeks of the yoga class, but how many yoga classes does he need and what is the total cost of that, right? That's what we need to figure out. So one yoga class we can see here burns 200 and he needs to burn 600, right? Which means that he needs 3 yoga classes per week. Oops. So he needs, so I'm actually going to put that. So I'll say here, 98 minus 86. to lose. And then he has, uh, let's just say needs 16 weeks to lose 12 kg. So I'll just give an I'll just say like i.e. So 16, nope, sorry, 12 divided by 0.75 equals 16 weeks. So again, you want to make it clear in whatever way possible. I'm just trying to make sure that I put all the information sort of in around near the boxes. Um, Now he needs to burn, what do you say? So 600 calories per week, which means he will lose 0.75 kilograms. So to get to that 600 calories, he needs to do 3 yoga classes per week, right? Because he needs to, it says 600 calories per week, and each yoga class will do just 200. So he needs 3 yoga classes per week. Needs 3 yoga classes per week, right? And the cost of that, like cost of yoga classes per week, so that would be, I'm just going to put it actually here. Sorry, a little bit a little bit all over the place to work, but hopefully, again, because there's not a lot of space on this paper, you'll be typing on the computer. So £6 per class multiplied by 3 classes equals 18 pounds per week. And he's going to do it for 16 weeks, as we calculated before. So if we do 18 pounds multiplied by 16, let's just do that. That would be, let's just see here, 288. Oops. 288, pounds for all of the yoga classes that he needs. Now let's also be clear on how many yoga classes he actually needs specifically. So he needs 16 weeks of 3 times per week. So that's 48 yoga classes. So I'm just going to say here, 3 classes per week, total 48 yoga classes, which means he needs to spend 288 is the total cost, right? So the answer is yes. Oops, because he only needs to spend 288 and he has a budget of 360, so he does have enough money. And in terms of explanation, again, essentially what I mentioned, but just making it, into a nice proper sentence. So this keeps happening. One second. Yep, sorry about that. We're back now. Yeah, so in terms of the explanation, so I'll just say he needs to lose 12 kilograms to become healthy, right? And I'm just writing this out. Um, um, and so I needs to do 300, what was it? Sorry. 3 yoga classes per week for 16 weeks. Uh, I'll just say for a total of 48 yoga classes. Just say total 48 yoga classes. There, I'll just say that therefore the total cost is 288, which is less than 300, what was it? 360, right? So you're directly explaining and answering the question, which is less than 360 pounds, right? So that's sort of the idea. You're making it clear that he does have enough money. So hopefully this answers the question. Great. So we're now on question 13. We can see a house tenant has a budget of 75 pounds to redecorate a room. The room has two walls, this much length, this much long, and the wall is this much high. One second, I'm just going to choose, put the black color back. And great. And so she wants to paint one long wall and one short wall. So let's say one long wall being this. Oops. She wants to paint this, and she wants to paint one short wall, which we can consider as this. And then she wants to put wallpaper on the other short and long walls. So the other short and long walls, if we just take a look, right? I'm just going to draw this out so it looks, like a 3D. And then so let's say this is the other one, long wall, and then this is the other short wall that she wants to put wallpaper on. A 2.5 liter tin of paint costs 16 pounds and covers 30 square meters. A roll of wallpaper is 52 centimeters wide and 10 meters long, and each wallpaper roll is 10 pounds. Great. Can the tenant decorate the room for the budget set? Okay, so first we can figure out the paint. Okay, so now we know that it covers 30 square meters and it costs 16 pounds. Okay, so first thing we need to do is figure out the area of what we're going to paint. So we're painting one long wall and one short wall. So the long wall will be 3.94 meters by 2.65, right? That's the height here. So with this red one here, okay? So we have long wall. Let me just do it I'll do it in red. So whatever's in red is for the paint. So I will have here 3.94 meters into 2.65 meters. And if we just pull out our calculator, 3.94 multiplied by 2.65, we'll get 10.441 square meters, right? That's the area of the long wall. And then the area of the short wall is 2.98 meters multiplied by 2.65 meters. So we will get 7.897 square meters. So the total of what we want to paint, the area is going to be 10.441 square meters plus 7.897 square meters. And so that gives us a total of 18.338 square meters. Okay, so that's how much we want to paint. So just from this, we already know that our tin of paint, it already covers 30 square meters and we only need to paint 18. So we only need one tin of paint. So I'm just going to say here, one tin of paint is fine. And then now she wants to put wallpaper on the other short and long walls. So now we already know that, because the other short and long walls have the same areas as the ones that we want to paint, we already know the total area of what we want to cover. right? So that means we want to, sorry. So 18, this is how much we want to paint, right? But this is also the same as how much we want to put wallpaper on as well. So 18.338 square meters is how much wallpaper we need. So we need to figure out how many rolls of wallpaper we need. So we have here two sort of measures of here we have two units. We have centimeters and we have meters. Now, given that we're dealing with our areas in square meters, we want to convert the centimeters into meters. So what I'm going to do is, so 52 centimeters is the same as 0.52 meters, right? Because there are 100 centimeters in meters. So if you just take 52 divide by 100, you get 0.52 meters. So that means the area of one roll of wallpaper. So I'll just say area of one roll. So that's going to be 0.52 meters multiplied by 10 meters, right? And that's going to be 5.2 square meters, right? And we need 18 square meters. So the number of rolls that we need, so I'm just going to maybe do it on the side here. We'll zoom out a little bit. So the number of rolls needed is equal to 18.338 square meters divided by 5.2 square meters. So if we do that division, 18.338 divided by 5.2, that gives us 3.5265. Approximately. I'm just, taking out the other digits, I'm rounding. And so this is approximately, since you can't have 3.5265 rolls of wallpaper, we're just going to say this is 4 rolls, right? So we need 4 rolls of wallpaper, and each one is 10 pounds. So we'll just do this multiplied by 4 rolls. So that gives us total cost of 40. And then we also have, again, 1 tin, right, for the paint. So then that should be fine. So if we do 40 plus 16, that's 56. And our budget was 75. So we have more than enough money to decorate the room within the budget. So what I'm going to do here, sorry, 1 second. I'm going to just tick yes here. And all the working that we've done, we'd want to put it here into the box here, right? So I'll just kind of summarize this. So area to paint is 18.338 square meters, which implies that 1 tin is enough. And then wallpaper needed, area of wallpaper is equal to 0.5. Actually, no, I don't need to write that out. I'll just write it as 5.2 square meters, which implies that we need 4 rolls of wallpaper. So 1 tin plus 4 rolls is the same as 16 plus 4 multiplied by 10, which is the same as 16 plus 40, right? Again, that's how much we need to spend on our rolls. So that gives us 56, and 56 is less than, I'm just going to use a less than symbol, is less than 75. So then if anything, you just want to say that they are below the budget of 75. Oh, sorry. As the cost is £56. Okay. So hopefully that answers the question. Here is all of the work that we have done for this question. And now we're going to move on to question 14. So with question 14 here, we can see that we have vet nurse in a pet rescue center records weights and ages of kittens brought to the center. And they've given us the weight and the age. One day the center receives an abandoned kitten. It weighs 460 grams. And we want to estimate the age of the kitten. So we want to draw a suitable graph and trend line. And then we estimate the age and show on the graph how we made the estimation. So essentially with this question, we want to do a scatter graph and do a line of best fit, or what's also referred to as a trend line. So what we're going to do here is we can see how, so the way you try to, I guess, devise up the units, I'm just trying to see. So we have here multiples of 2 as well. I think what we can do, 10, 20, and a maximum we have for days is 50, right? And the weight, we want to, technically we could, I'm just trying to see, invert, because we would have the same relationship. So what we want to do with a graph is we want to first have our axes. So it's a little bit more difficult here. I'm just going to do it here. So here we have 10, and then here we have 20, 30, 40, and 50 days. So this is like age. So let me just put it here. Age in days. And then here we have, so if this is going to be our 0, then this is going to be, over here we're going to have, how do we want to go? 1 second. So we have 180 all the way till 720. Okay, so I think what would be best is to just go up by 100. And I think, yeah, we just go like 720, like there's nothing in the units digit. So we can just go by 100, 200, 300, 400, and leave according spaces. So here we have 100, 200, 300, might not be enough space actually. 400, yeah, 400 here, 500 here. That wouldn't be enough space. So what we want to do is actually move this to the bottom. So I will just move this down here, which they haven't given enough space, honestly, to draw this, in my opinion. But we shall continue. So 100, 200, 300, 400, 500, 600, and we go to 720. Okay, I'm not sure how we would try to fit that in. Let me take a look and see. Okay, so what I've done is I've just shrunk our vertical axis down. So we're going from 100 to 800, right? Because our maximum number is 720. So, and then we're going to label the vertical axis. So this is going to be our weight in grams. Okay. And one of the other things we're going to need is a title. That's always very important. So this is going to be weight versus age of the kittens, right? So I'll just say weight versus age of kittens. And then we just want to start plotting this, right? So 14 days 14. I'm just going to start from the lowest number I see, and we're going to go to 180. So 14 is right here, and then 180, sorry, it's going to be right here. And then we want to move on. So 28 will be 420. So 28. Will be here, and then 420 is going to be here. And then we have 56, we have 720. So actually, so this should go up to 60. Right, and then 56, which is going to be here. Sorry, we have 720. 56 and 720. So that's going to be right here. Then we have 50 and 660. So 50 is here, and 660, 20, 40, 60 is going to be here. Then we have at 20 days, we have a cat that weighs 360. Going to be right here. 42 days, we have 480. So 42 days is going to be 480 is going to be right there. And then 340 at 28 days. So 28 again, and we have one at 340 versus 420. So we're going to go to 28, and we'll go to 340. It's going to be right here. And lastly, at 50, we have 600. Great. So this is what our scatter plot should look like. And now we want to draw a trend line. So for that, we're going to need a ruler. So 1 second, ruler. Great. And now what we want to do when we draw trend lines is you want to essentially have more or less half of the points on one side and half of the points on the other side. So, I mean, in this case, it's a little bit more tricky, and we're not exactly going to have that, but we just want to draw something that reflects, you know, the general trend. So we can see the line is more or less like this. And I'm going to move this maybe, oops. Yep. And so I want to draw this. Put it like this. I'm going to draw it in red. There we go. So now if I get rid of the ruler, that's more or less a trend line, we could say. So now from this trend line, we want to estimate the age of the abandoned kitten that we found, which is 460 grams. So we want to estimate what age the kitten could be. So following our trend line, what was the number? 460. So from 460, I'm going to use it in blue. So 460 is right here, this line. So at 460, we intersect the axis right here. Not the axis, sorry, but the trend line here. So this is 31, 32, 33. So based on our trend line, we can estimate the age of the kitten that weighs 460 grams is going to be 33 days. Hopefully that is clear. And by drawing this, this is how we showed on the graph that we made the estimation. So I'm just going to circle this point. Sorry. There we go. So now it's very clear how we found from 460. So I'm just going to write here 460 as well to make it extra clear. So that's how you would answer this question here. And now moving on to the last question, question 15. So a city council wants to encourage car sharing to cut pollution, and it takes a survey of the cars and finds that the mean average number of people in a car, so in a single car entering the city, so there's on average 1.65 people per car, and the mode, which is the most frequent number of people in a specific car, is going to be 1. So most of the cars coming into the city have 1 person, but the average is around 1.65. So it introduces a congestion charge for cars only with 1 person, right? So that's why it's, generally you would say that's a good idea, because if most of the people is 1 and you want to increase that number, you want to charge people for only having 1 person in the car. And it wants to know if the charge is effective in making people share cars, and it does another survey. And we have the information given here. Is the congestion charge effective? Make 2 comments using the figures provided. So what we want to do here is we want to figure out the mean of this, right? And the mode, because that's what we're comparing here. We're trying to see if this number and this number change given this data, right? Given their congestion charge. This is the number, this is the data they've collected after the charge is introduced. So how do we figure out the average of all these numbers? So we have 17 ones, right? So it says the frequency. So this is the number of cars with 1 people in it. So we have 17 ones, 54 twos, 14 threes, 8 fours, 2 fives, and 0 sixes, right? So we just want to get all those numbers, add it, and then divide it by the total number of cars, right? So we have 17 plus 54 plus 14 plus 8 plus 2 cars that have come through, and then this is how we break them down, right? So the total number of people, we can do this. So 1 multiplied by 17 plus 2 multiplied by 54 plus 3 multiplied by 14 plus 4 multiplied by 8 plus 5 multiplied by 2 plus, well then 6 plus is 0. So we'll just leave that. So doing that on our calculator, actually what I'll do is I'll just write it here. So this will be better. Multiplied by 1, multiplied by 2, multiplied by 3. Right, and 6 times 0 is 6. So let me actually get rid of this just so we have space. So this is going to be 17. This is going to be 108. This is going to be 42. This is going to be 32. This is going to be 10. And then, well, this is 0. Just write it out. And so then the sum of all these numbers, right? 17 plus 108 plus 42 plus 32 plus 10. So we have 209, right? That's the total number of people, you could say, I guess, right? That have entered the city. So we have 209 people, and in how many cars, right? So that we can figure out the average number of people in a single car. So we have a total of, so to figure out the number of cars, we have 17 plus 54 plus 14 plus 8 plus 2, right? And then there's 0 in the end anyway. So we have 95 cars and 209 people. So the average, you could say like the average the average number of people in a single car is just, so I'll just say here, average number of people in a car is 209. I'm going to just use this / as a divide. 95. That's going to be 2.2. Okay, and then what do you say? The mode is just the most frequent number of people in a car, right? So if we wrote out like 1 17 times, 2 54 times, so on and so forth, we'll realize obviously that 2 is the most frequent number. So our mode is 2 now, right? So if we compare 2.2 and 2, we can see now this has become 2.2 and this has become 2. So the average, so after this congestion charge that they've made, we can see that the average people in a car entering the city has now increased to 2.2, and the mode is 2. Like that's the most frequent number. So in both aspects, the average has gone up. So is the congestion charge effective? Yes, right? Because their goal was to get more people sharing a car to cut pollution, and doing this congestion charge has done so. So for this part here, the two comments that they want you to make is with respective to the two, figures that we're trying to compare, right? So we have mean and we have mode, right? So we want to say here that the congestion charge is effective as the mean has increased from 1.65 to 2.2. And then we say again, the congestion charge is effective as the mode has increased from 1 to 2, right? So in both cases, again, we have increased. So overall, the congestion charge is effective, and that's how you would answer this question. So we have now essentially reached the end of the exam. This is just a spare graph paper for question 14, which is this question we did here. Thank you so much for watching and listening to this video. Have a great day.